Hello and welcome to the lecture series on 8051 microcontroller. Uh, we were basically discussing one problem, and it was to write a program to generate a square pulse, train of pulses of frequency 1 kilohertz. So I would request you to see my earlier lecture so that I have explained the things which we are using in this program, and the program would be much easier to comprehend. So let's start by running program in a step-by-step fashion. So let me start by pressing the step button. So the first instruction is clear P1.1. So basically it makes the pin 2 of port 1 equals to 0. Then a call delay will produce a delay of 500 microseconds. So when the output is 0 and it is maintained 0 for 500 microseconds. Let's see what happens next. We press step. Now the delay has been called. So you could see here the program counter has been uploaded with the address 000A, which is the address where the delay subroutine has been written. And moreover, stack pointer, stack pointer, uh, we will talk about it. Let me press step once more. Okay, now move dmod 01h. So 01 is stored in tmod. Tmod is timer mod register. It is an SFR, and by writing 01h we are basically making the least significant bit of tmod equal to 1. So that refers to basically selection of the mode. So let me see tmod register here. So tmod is here, tmod. So just wait a minute. Okay, just see this tmod register here. So the lower two bits, they are for timer 0 mode selection. So if I'm writing 01 here, it would mean that timer 0 will operate in mode 1. Moreover, this is also 0, which means that timer has been selected. So we are not making the timer run as a counter, but we want the timer to run as a timer. So, and this gate is again equal to 0. So making it 0 essentially would mean that we are disabling any external interrupt. While all of the higher 4 bits are 0 here, that means we are not interested in using the timer 1. So let's move back to the program. So we can see tmod. Uh, its address is 89h. So let me write 89 here, 89, and sorry, 89, and okay, there's some problem here. Anyway, so tmod has been given a value 01, so we could see here. So next again I press tab. So now 0C has been saved in TL0. So this is the count that has to be put in timer 0. So lower 8 bits of timer 0 needs to be stored with the value of 0C, and the higher 8 bits need to be stored with FE, and that would correspond to generating a delay of 500 microseconds. So TL0 gets a value of 0C. So you can see here. Then again pressing step, and FE gets stored in TH0. So you could see here TH0 is FE. Then oh, okay, then Next instruction is a tcon, and let's see tcon register. Tcon is here. So the higher 4 bits of tcon is used for the timers, and the lower 4 bits for interrupts. And since we are using the timer 0, so we are interested in TF0 and TR0. TR0, when it is set, that would mean that we have started the timer 0, and when there is an overflow, then TF0 becomes 1. So let's observe this in our program, in the simulation. So when I press step again, so tcon becomes 1 0. 1 0 means now counter has started to count. Okay, so timer is this TL0 and TH0. So you could see when I will start pressing step, so the value will get incremented. Okay, so I'm pressing a step, and it is checking whether TF has been 0 or not. So TF0, TF0, we couldn't, I couldn't find it here. TF0, TF0 is basically a bit of Tmod register, uh, a T0 register, sorry. So if I can write T0 here, I don't know if it work or not. Let me just check it out. T0. So if I, no, it's not working. Any other way to do it? No. So it's a bit addressable mode only. So Tmod is not bit addressable, so we could not see that here. Anyway, tcon. Okay, tcon. Let me see if we can get the content of tcon, because tcon is a bit addressable. Yes, so we are getting 0 1 here. Okay, so 1 here means we have started the timer. Okay, we have started the timer. So if I press step and step and step, just see here the count is increasing. Okay, so earlier it was 0C and it is incrementing. So I need to put some breakpoint, which I have put here. So when I press run, then it will come to this point. Okay, and it will do many a times this operation JNB till TF0 becomes equal to 1. TF0 equals to 1. Let me see if we could see T0 register. If it is bit addressable, we could see here. No, it's not bit addressable. Okay, yeah, we could find THN1 and TL1 here. Where is, yes, TH0 and TL0 here, but okay. Anyway, so let me run the program. So when I pushed the button, so you could see that TL0 is increasing very fast. So let me pause it and run it a bit more faster by increasing this frequency 200. So I press run again, and now it quickly moves to this point. Okay, just see the program counter is now pointing to 0004H, and this, as expected, has reached a value 00, and it has overflown. Is it fine? So the control has moved to this point. Okay, so you could see that the delay that has been generated is 515 microseconds. So, and it took 259 instructions. So basically it included all the instructions, this and this, and uh, and here also these instructions, this and this, and then finally 200. This is executed a number of times, and finally 515 microseconds uh, is the time that has been taken to reach this point. Okay, it includes the 500 microsecond delay that has been generated, and the output is 0 here at p1.2. So let me put a breakpoint here again, so that we could see uh, uh, that it becomes 1. If I press 1 a step again, then this becomes 1. Just see here, and then I'm running it. So when I run it, so just quickly becomes 0, overflows occurs, and again a delay of 500 microsecond, and some more instructions have been evaluated, so this extra delay is there, and that basically refers to the time taken by the program to reach this point. So it remains 1 for 500 milliseconds, and this process will continue. And if I remove this breakpoint, remove the breakpoint, okay, remove all breakpoints, and if I run the program, then just see here what is happening. 0 1 0 1, and this basically is getting incremented to uh, to value 1 after every 500 microsecond, and then it reverts back to the value 0. So I hope you understood this program. So a bit simple, uh, and thank you for watching.